Okay, we're going to look at using unit rates on graphs. So we're going to start with a really quick review question. Determine whether each graph represents equivalent ratios. I'll give you a hint, those of you that don't have a straight edge or ruler, you can go and do that. It will be very helpful for you in determining if they are ratios. You remember what that definition is. It'll give you like a minute and a half to do that. Because all you needed to do was put your ruler down on origin, draw a line through it. This one, when I put my ruler on it, does it go through origin? No. So what does that tell you?
It's not.
It is not. So what about part one? Yes. Why? There's two aspects. It's a straight line and it goes through origin. That means it's a ratio. This one, although for number two, although it's a straight line, it does not go through origin. That means there is a relationship between them, but it is not a ratio relationship. Everybody good on that? Okay. Let's go ahead and turn the page. On this one, in cars, the speedometer shows the driver the rate at which the car is moving, its speed. Many speedometers are like double number lines arranged in a circular shape. The numbers on the outside show the rate in miles per hour, and the numbers on the inside show the rate in kilometers per hour. So you literally have a double number line. It's just a round one. You can use this to estimate the rates. So we've given you three different ones to do. See if you guys can figure these out. We'll give you like 2 minutes on this one. On this one, it should have been relatively easy, guys. So all you got to do, at what rate, kilometers per hour, at 60 miles per hour. So all I do is I go to the miles per hour on the outside, and I say, okay, there's 60. So what rate was that in kilometers? About 100, because it's halfway between the 80 and the 120. Does that make sense? And they did it kilometers per hour. About what miles per hour if it's 60 kilometers per hour? So now we're looking on the inside scale. Here's our 60, and what do you see? What do you see?
30 miles per hour.
Well, actually, 30 would be here, right? So it's kind of about halfway between 30 and 35. So I would take 35 to 36. I would probably go 36. But as long as you're within 2 or 3 of that, you're just fine. But if you said 20, then you're too far out. Does everybody understand where that one came from? Actually, let me ask the comments. Anyone not understand where it came from? Good. Thank you for being honest. So on this one, I was looking at 60 kilometers per hour, right? So I need to find 60 on the inside because the inside is my kilometers per hour. So right here is 60 because it's halfway between 40 and 80. And then I now switch to the outside. Now it's between the 30 and the 40, but it's kind of a little towards the 40. That's why I said 36 instead of 35. But either of those would have been good. Got it now? Good. About how long would it take to drive 90 kilometers at 55 miles per hour? So on this one, I'm going to erase the other marks we've already done. Wow, that's pretty cool. I don't know where those came from.
Whoa.
I know, that's what I said. Guys, slide down. So, let me get rid of those. Dang, there's a bunch of them on there. Guys, slide down, please. So again, the key is that 90 kilometers is how far I need to go, right? So if I look on the inside, this is 80 kilometers, that's 90 kilometers, or 100 kilometers. So 90 is going to be somewhere in between those two, right? So if I look at how many miles per hour that is, so I need to figure out how long it's going to take. That point right there is about halfway between 50 and 55, isn't it? So if 90 kilometers is equivalent to 55 miles per hour, how long will it take him to go 90 kilometers? An hour. So anyone who doesn't understand the logic on that. And they ask you to explain your reasoning because 55 miles per hour is about equal to 90 kilometers per hour. Does everybody understand how we did that one? Okay, let's go turn the page. Now we're going to do on incline one. The Duquesne incline opened in 1877 to move coal workers from their homes atop Mount Washington out of the coal factories along the river. The Duquesne incline still transports commuters who live in the area. Jasmine takes the incline to work each morning. The incline is 800 feet long, and it takes 90 seconds to ride from the top of Mount Washington to the bottom. So identify the true statements. Explain your reasoning for each. So we've given you 5 of them. You have your base information. Go ahead and do all 5. And then when you have time, go ahead and start number 2. So we'll give you guys about 8 minutes to do this page. Go ahead and get started. What we were paused is, if I take my original rate, 800 feet in 90 seconds, and turn it into a unit rate. This is directly off your homework last class, guys. And the one I told you is use the smaller number. So find out how far it goes in 1 second. 90 down to 1, I'm going to what? Divide by 90. So if I take 800 and divide by 90, I'm going to just do a rough approximation. This is almost 810. So it's going to be just a little less than 9 feet per second. So if I'm going at 9 feet per second, how far am I going to go in 20 seconds? How do I go from 1 to 20? That's 20. So 9 times 20 is going to be 180. Guys, the number should be easy because we're doing approximations. Is 180 close to 178? So this would be a true statement. 178 is close to 180. Okay? Technically, we should have the units on those. Okay, what about 600 per minute? How many seconds are in a minute? 60. So 1 times 60 gives me the 60. What's 9 times 60 give me? 540. Is that close to 600? Yeah, I would not put that one that close. So for me, B is the one that is false. Now, 75 seconds is 750. So 1 times 75 gives me 75. 9 times 75, well, 9 is almost 10, right? Is that going to be close to 750?
Yeah.
That was actually pretty close. So this one is true, but not exact. It's a little bit far. Okay, she does about 44 feet every 5 seconds. So my 1 times 5, so 9 times 5 is 45. Is that close to 44? That's actually really close because we know it's actually a little under 9, right? So it should have been a little under 45. So this one is true. It's the closest so far. And then our last one. She travels about 8 and 9/10 feet per second. We have to do the math. That's probably the true rate right there. Okay, so this one is also true. And this is the best answer yet. Does everybody understand the process for doing those? CJ, I apologize. That's not a helicopter blade. It's a ruler. Please take it off your pencil. Now we're going to plot the correct ratios from question 1 on the coordinate plane. So we're going to go back to our question 1 and say, okay, the ones that are true. So we had 178 in 20 seconds. So 20 178 would be just less than the 200. We had the 75 and 750, so 60, 70, 75. 750 is going to be the next one up, so somewhere in that area. We had another one that was true at 44 feet in 5 seconds. So 5 seconds, 44 is going to be just below the 50 mark. And the one we really can't do because one's not on there, but that should give you enough that if you use your ruler and lay it down, you can actually draw a relatively accurate line. You know it's 0 feet, you have 0 seconds, so it is the ratio. We started here, and your line should go somewhere like that. Does that make sense for everybody?
Yep.
Any questions on any of those exercises we just did? Okay, let's go ahead and turn the page. We're not going to do this golden ratio one. 10 minutes left in class. So let's go to page 337. On this one, the 6th grade chorus made and sold their own mixture of trail mix and soccer games to raise money. During the first soccer game, they sold 1-pound bags for $2.80. They got many requests to sell different sized bags of their trail mix. The group decided to vary the size of the bags, but wanted to make sure that the cost of pounds stayed the same. In other words, they weren't going to penalize someone for buying more or less. So your task, complete the table. To display the cost of various quantities, create a graph from your table of values, and then identify 2 points on the graph that represent unit rates. Write each unit rate in words and explain its meaning. So there's 2 parts. Write it in words and explain its meaning. So there's a lot to unlock on this page. First thing you're going to do is build your table. Then from the table, you're going to plot the values to get the cost. And then I'm going to have 2 unit rates. Okay? I'll give you a hint. Your unit rates are when the values are 1. Questions on what you're doing? Okay, we'll give you guys about 10 minutes to do this page. Go and get started. Okay, so we gave the tip of, they told you that the one was $2.80. I'm just going to show you how my brain works, but there are a ton of different ways you can do this. I try to look for the easy ways. So for me, the easy way is, well, half of 1 is 5/10, yes? It's really easy to take half of 280, that's just 140. Once I have that one, now 2 at 25 is half of that, so that's going to be 70 cents. So I now have all the parts that I need to build the rest of my table. 75, 5/10 is 2,500, gives me 7,500, so I just add these 2 up. 125 is the 1 plus 25, so I add 75 cents to this one, so 350. And then 1.5 is just the 1 plus 150, so I add those 2 up and I get 420.
Yeah.
So regardless of how you did it, those numbers are the ones you should have gotten on your table. Once you have the numbers on your table, now you just need to transfer that to the graph. So the first one I personally would have done is the 1 and the 280. So I come out to 1, I come up to 2, and then I realize there's 5 between each. That means each one is 20 cents. So that's going to be right here will be my actual plotted point. 0.5 is another one that should be relatively easy because it's right on a spot. So at 5, I go up to 1 and 4/10. I now have 2 points on my graph. You can now use a straight edge in order to draw your line. Apologize for the cough. But we start at origin, and it should go right through each of those lines. Remove my, I figure out how to do this part with this. Okay. So now that we've got this, we should be able to go ahead and find our ones. At least good for approximation. We already gave 1, so 2 points on the graph that are unit rate. I know that, does anybody notice a problem with this graph? Because I'm assuming they actually based this graph on what I saw in a lot of your tests.
Oh.
because your tests are also missing something very important. Cameron? Label, thank you. So, looking at my chart, this one has the decimals, so this was probably what they did for the weight in pounds. And this one was probably my cost in dollars. Okay? So my unit rates are at 1 pound, it costs me $2.80 to $2.80. And the other one is, what does 1 pound cost? That's going to be about 40 cents. And then, I know $1 gets me about 4/10 of a pound. So those are your 2 unit rates. So this one just says I pay $2.80 for each pound. And this one says for $1, I can get 4/10 of a pound of mix. Does everyone understand those unit rates and how they're different? Yes?
Aren't you supposed to put LB instead of
You, yeah. Good catch. So, does everybody understand everything we did on that? Okay, we're down to just a few minutes. So let's go to our homework. Page 239. Please stay quiet because I've got a lot I want to try to cover on this for you. Describe in your own words how you identify unit rate from a graph of equivalent rate. We should be able to do that. I just gave you a prime example. Look at what I looked at for each axis on the last problem. That should answer that for you. At ShopRite, you spent $7.15 for 5.5 pounds. Graph the relationship to help you answer the questions. So the first thing you should do is graph the relationship. The nice thing is they already gave me 1 point. I know that another point is at 0, 0. If you have 2 points, you can draw a line. Once you have the line drawn with a straight edge, and let me say that again, with a straight edge. If you don't draw it with a straight edge, you can't do anything else with it. But if you've drawn it with a straight edge, you can now say at 1 pound, how much do the potatoes cost? You go up to the line, then you come over. That will give you the cost. How many pounds can you get for $1? So then I come to the $1 and I go over to my line and I say, how many pounds did I get? About how much does 17 pounds of potatoes cost? You realize 17 pounds is halfway between 16 and 18. How many pounds of potatoes do you get for $13? So I come up on this axis. Here's your 13. Guys, use your lines to answer all these questions. Make it easy for you. They told you could use the graph. When I go to the back page, now determine the unit rate from each graph. Pardon my cough again. That's the unit rate is going to be easy on this one, and it only said a unit rate, so you don't have to do both. So find a unit rate on each one. In other words, find what it does for every one. That's what a unit rate is. Then the last one, graph the rates in each parent according to plane. Explain whether or not they are equivalent. That was our opening exercise today. How do we know if they're equivalent? They'll go through origin, but more importantly on this one, if they're equivalent, it's going to be the same line. So plot the points that they've given you, draw them through origin. If it's the same line, that means that they are equivalent. Questions on what you need to do on this? Okay, your homework should be relatively easy. I will stress again. You must use a straight edge for your line. I got really tired of grading the test and grading the homework that people were freehanding this stuff. The whole idea on lines, they allow you to make predictions. But you can't make predictions if your line is not accurate. Okay, good luck on this one, guys.